The next speaker is Enrico Babilio.
Hi. So I share my screen.
Yes, he will talk about adaptive tensegrity shells serving as solar facades. It's a paper in.
Do you see my screen?
Yes, it's a paper in collaboration with Raffaele Miranda, Narinder Singh, Amendola, and Fernando Fraternali. Please go ahead, Enrico.
Okay, thank you, Andrea, and thank you to the organizer for the opportunity to be here. So the work I'm going to show you is something in progress. We have some results already, but some other stuff has to be done to make this kind of idea something usable in reality, let's say. For now, it's just kind of concept, and we have some numerical results to show what happens, let's say. So how you know, actually, also from the previous presentation, there is kind of need to save energy using the solar facades. Actually, I'm not an expert in technology of architecture, but at least I understand that if you have some sun energy entering in your building, you have to make to use some machine to control the temperature. So if you try to consider to protect the building using a kind of morphing facade, it could be actually a good idea, but this is not new actually. And the inspiration for this job comes from this kind of building. Is in Abu Dhabi, is named the Albar Towers, and they use this structure that is. Do you see my pointer?
Yes.
Okay, here there is kind of piston, and it applies some motion to this elements to close or open the windows. Let's say we try to change a little bit this concept and introduce the motion not using a piston in the middle of this kind of element, but using kind of strings around this triangle. The concept is like this actually, where these are strings and these are elements, plain elements that are on positioned on bar. So this kind of on graph give you some idea about the structure. So you have in red springs, in black bars, and these springs and kind of actuator here. So I won't just go ahead to save time as possible. Here you see 6 configuration you can achieve just making different strain along red strings. Here hue is just a parameter to take this kind of strain along the strings. Here, sorry, here is the minimum strain. Not actually 0. Here is the contrary. So the maximum strain here, the minimum strain here, and this the configuration with the window completely open and the window completely closed. So then the next step is just considering to equip this system with a system of deep bars that have again in red strings, and these strings now are think as piezoelectric strings, just to try to store electric energy. Here is just an animation of the process of opening, and here what you can obtain as vibration under wind loading. Here on the we see the pressure, which is computed by using quite standard statistical measures. And this the height of the central point during the simulation. My time is already done, but I'm finished.
Just you have 1 more minute.
Okay, so this is just a sketch of this kind of piezoelectric string. The design is in collaboration with Felipe Aramante dos Santos of Faculty of Sciences and Technology of the University of Lisbon, and actually it's kind of nylon cable with I don't know the English. This helicoidal, helicoidal strings along this core, and these are of piezoelectric materials, which is this one. The last thing, of course, piezo materials is not that. His ability to store energy is not that much. It's just a few watt hour over a square meter, or under wind, just a few milliwatt per hour over square meter. But the idea is that you can use this energy just to store the energy necessary for a little device or something like that. That's it. So thank you for attention, and please, sorry if I
no, it's perfect. It's in time. It's in time. No problem. Okay. So I don't see question in the chat. If somebody has a question now, you can talk. Otherwise, of course, I'm very curious about a few things.
Yes.
So I will start first then. So I was wondering if you are looking for some other, also at some other geometry. So this is inspired by the Al-Bahar design. Maybe, do you think you can apply similar method to other pattern? I don't know, maybe.
Okay, yeah. Actually, as you already said, we just consider this kind of structure, and actually we didn't check a different geometry, but at least in principle, I think it is possible. You just have to check something like this. So you have to have something that is leaves just 1 degree of freedom in order you can move up and down if you need this kind of structure. So in principle, I think there are a lot of possibilities to consider different geometry. The only one requirement is you have to have a system controlled by just 1 parameter. Here it was this kind of U, which is actually the amplitude of the displacement of this guy, or if you want, it is actually related with the strain of this.
Okay, thank you. So also another thing, I don't know if you mentioned this, but is there a self-logging system? So after you actuate, you lock it so that when it's loaded by wind,
yeah, you are right. You got the point. The idea is exactly this. When you close completely the screen, you can think to lock the system and just to save the energy. You don't need to have the engine still on. So when you need to close the system again, or if you prefer to open the window again, you unlock the system. Actually, I have to say that this is just an idea. I can understand that this kind of lock or unlock system is just kind of hook, but we didn't.
Yes, no, I actually had previous experience with this kind of method to help the structure. Okay, thank you very much, Enrico. I will. For you, especially for keeping the time very well, also for the nice presentation.